Right now, we stand between the crossroads of ancient medicine and that focused on intangible ideas to cure medicine. They focused on spirituality, they focused on mindset, and they believe that's how a person could overcome disease. And modern medicine that focused on tangible traits. It focused on what makes a person in the sense of medicine and vaccines and how that overcomes us. And it is no better said than one of the fathers of medicine, Hippocrates, who said, "It is more important to know what sort of person has a disease than to know what sort of disease a person has." When he said this, he was absolutely correct. However, when you think about the context which he said it in, he is completely wrong. It's not the intangible traits that we should be focusing on. It's not the mindset of the person which he believed was the correct answer, but it's the tangible traits that modern medicine tells us. It is the DNA that will let us change how medicine works, to make it more precise, and to let us win these battles within us, to let us win wars within us. And that's no better seen than CRISPR versus cancer and the war within us. Using CRISPR-mediated immunotherapy to once and for all clear cancer from our bodies. This can be seen specifically in how CRISPR is being used. CRISPR is a genetic modifying tool that goes into the human genome, finds the certain DNA that a scientist wants to edit, attaches onto that piece of DNA, cuts it out, and then, with the help of scientists, they implant the desired DNA to be able to fight back and enhance the immune system, and then their problem is theoretically solved. Hopefully. Science doesn't always go the way that scientists intend to, and there is still a lot of innovation with just this technology. Now, with CRISPR, we can address the main problems of cancer. The best way that I can describe cancer to y'all is that it's a sniper in a forest. It's camouflaged and it's deadly. The immune system can't find it and it can't deal with it, and it's rapidly hurting the host's body. He's right there if you haven't spotted him by now. And the only way that we can treat cancer as of current harms our body. Among the common types of symptoms that we see with losing hair, coughing up blood, there's a much more harmful one, and that's we can accidentally give the patient another tumor, which serves to set back progress in treating the person's cancer, considering 2 cancers is probably worse than 1. Now, we can use CRISPR to supercharge the immune system, to make our immune system more powerful, to invigorate our immune system, and to make it so it produces more help. It calls in friends. Specifically, with different scientific perspectives and finding certain genes to target, we've realized that we can make our immune system cells universal. By taking a certain receptor, we can attach it onto our immune system cells, or T cells, to make it so they can recognize all forms of cancer, and that we can take healthy patient T cells and put them into sickly patient T cells. So that way they have the strength of a healthy person fighting against this deadly illness. We can also make it so that the immune system can better target the cancer. We can get rid of the camouflage factor by making it so our actual immune cells can spot the cancer, saving the need for chemotherapy and radiation. We can also make it so T cells can better force apoptosis. We can make it so we can clear out the tumor more efficiently and safer by inducing that programmed cell death, or apoptosis, within the cancer cell. But that isn't the only way. We can invigorate it. We can have it be more expressed in the human genome, so there's more of these supercharged cells to be able to fight all the forms of cancer and actually clear all of it. We can also turn off and on these T cell expressions to encourage certain T cells when they're attacking cancer and discourage other T cells when they're harming healthy cells, because that, once again, is another problem with current treatments. We can also make it so it's more resistant to the tumor microenvironment, that the tumor can't as easily fight back against its treatment. But I'll talk more about that later in my presentation. And then thirdly, we can produce more cytokines, or these little tiny proteins that go into the tumor cell and help force apoptosis. We can create them faster, meaning there's more of them. We can deliver more of them to the tumor cell. And then we can make it so that these smaller proteins are actually able to infiltrate the tumor cells more severely and actually clear all of it as opposed to just some of it, which it would then expand back to what it was before the treatment. We can also look at the tumors, though. As tumors are a part of our DNA, we're able to use CRISPR to change how they work. We're able to make them more susceptible to our immune system, so they become an everyday virus or infection. We can reveal them. We can strip them of their camouflage, so that way the immune system in its entirety, and not just T cells, are able to focus and find the tumor and get rid of it. We can also weaken its tumor microenvironment. By removing its harmful effects, the tumor is less likely to be able to fight back and disable our immune system, which not only means that we're able to clear the immune system, but it means that we won't run into issues where our immune system drops because we have cancer, meaning we're more susceptible to other viruses. And finally, and by far the most important one, is we can slow the growth of the tumor. This not only helps us cure it and buys more time for the doctors to get rid of the entire tumor, it buys more time for the patient to spend with their loved ones. It buys more time for them to fight back. And by far, the most important of the three factors is it gives them hope. It gives them hope that they'll be able to live a normal life that they normally won't be able to with this type of disease. Now, when I looked at all my research, all these different scientific perspectives, combined the similarities of the trials, and saw the different success rates in the two different types of trials, rat trials and clinical trials. In rat trials, there was a 50 to 80% efficacy rate in controlling the tumor. That is great news and a huge success. That means, at least for mice, we are at the pinnacle of being able to stop their cancers. However, when it came to clinical trials and actually testing it in the entire human environment, there was only a 10 to 50% efficacy rate in controlling the tumor, meaning there is still a lot of research needed to be done for this special type of disease. However, I would like to mention that not all hope is lost. Most of these clinical trials, and even most of the rat trials, only focused on one perspective, and of that one perspective, only focused on one gene, maybe two, meaning that they might have strengthened the T cell, but they only did it through one method, which is why in my future research, I would like to be able to combine these different perspectives, looking at both weakening the tumor and also supercharging the immune system to be able to find and gain more control over the tumors. Which is why I would like to ask y'all to help get people off Cancer Row, to support CRISPR, to support medicine, to support science, so that we can change the first words of the definition of cancer from cancer is to cancer was. Thank you for listening.